Alright guys, welcome back to another video. We're gonna prove that the limit as x equals to, or x approaches 0 of 1 plus x raised to the 1 over x is equal to e. So how do we achieve that? So first of all, we need to let this expression be equal to an equation. So let's do that. 1 over x, we're gonna equal that to simply y. When we do that, let's take the natural log of both sides of the equation. Let's go from there. So I'm going to take the ln of 1 plus x raised to the 1 over x. And every time we take a natural log of a number or a base that has a power, that can also be interpreted as b ln of x. So therefore, we have ln y equals to the limit as x approaches 0 of 1 over x ln of 1 plus x all over 1. That's the same. And so if we add the 0 here, so for our limit function here, so we have ln as x approaches 0, we have 1 over 0 times ln of 1 plus 0 all over 1. This is equal to ln 1 over 0, but we know that ln 1 is equal to 0. Therefore, we get 0 over 0. And whenever that happens, we can use L'Hopital's rule. That's what I have here. So every time that happens, that satisfies 0 over 0, then we can use L'Hopital's, and basically what it says is the limit of f of x as f over gx as x as a constant c is the same as taking the derivative of both and then adding the constant there. So that's basically what it is. So we're going to apply that technique, L'Hopital's rule. So we have ln of y equal to the limit as x approaches 0. We take the derivative with respect to x of ln 1 plus x over the derivative with respect to x of x. So when I do that, keep in mind that the derivative of ln x is equal to 1 over x times x prime. So basically the derivative of x as well. So if ln 1 plus x happens to be all of this is what we consider x now. So therefore, when I take the derivative, we take the derivative with respect to x, that will be equal to 1 over x, which is 1 plus x, and then times the derivative of what's inside here. So we only have a first degree, so therefore it's times 1. So that will equal to 1 over 1 plus x. That is our derivative for that. Then here we have 1 over 1 plus x. And down here, the derivative of x is simply 1. Oops. Then therefore, this is equal to 1 over 1. Go back. 1 plus x. That's our solution so far. So we go back and we still have ln y equals to the limit as x approaches 0 of 1 over 1 plus x. We still haven't finished here. We need to use the logarithmic rule. Once again, ln of any number, when we add the base e to both sides, is equal to simply x just like that, right? So now let's do that here. We will add base e to both sides of the equation, so ln base e equals to limit as x approaches 0 of 1 over 1 plus x, and then we need base e here as well. So if we continue, we get a cancellation here for ln and e, and we get y equals to the limit as x approaches 0 of e raised to the 1 over 1 plus x. And now if we're ready to apply the limit function, we get limit as x approaches 0 of 1 over 1 plus 1 over added 0 now for my x there. So let's put a different color here. So x is 0 there. It's equal to e there. So therefore I get e raised to the 1 over 1 plus 0, which basically is, at this point, is e by itself. That's how you find the solution for this type of problem. In my next video, I will be working off this problem. So stay tuned. If you like what you're seeing, please subscribe and allow others to see my content. Thank you so much for watching, and stay tuned. Goodbye.